Hi everyone. So I am again here with my new topic. This is my lecture number 3. So for lecture number 3, I have chosen one physical chemistry topic from chemical kinetics. As we are targeting CSIR NET June 2024, it is actually not much time is left for that. Within 1 month, exam will happen. So for that reason, actually to help you with some new topics. Actually, our idea is to introduce you various kind of topics from physical, inorganic, and organic. Uh, from the all portion. So that's why I have chosen different kind of topics to you, so that you will find it under interesting, and you will start solving the questions with the basic idea. So about the chemical kinetics, I will say that it is not much tough topic, because the concepts actually are known from our school days. Actually, school there was a chapter. So in that point of view, you can say that it is easy. But the question solving, is it easy for the question solving or examination point of view? That is a difficult question to answer, because here various kind of concepts are there. Like sometimes students are stuck with a basic topic that is um, uh, uh, actually worse, because if you start with a hard question, to think about a hard question, that you'll know that I don't know it, I will think some time. If I can solve, I will solve, rather than I will pass it. But if you start with a easy topic in the exam hall, that is more frustrating, right? And here in this topic, actually there are few things that will create a problem in the from the when you start the practicing the questions. So that's why I am here to actually to make you understand with these basic ideas and clear your all confusion. Okay, so it will be like the topic will be rate of reaction, rate law, and order of reaction. Just clear cut idea about all these things, how these actually we will measure, or we will read, and how the actually we will solve the question. That is my purpose. I will not go into the various expression, how it is coming and not. This kind of things are actually there in chemical kinetics, but I will not go into more detail about it, because my purpose is to solve the question more, because only 1 month is left. So let's start with the topic. Okay, let's start. So first, okay. So in every if we say chemistry, everyone, like for a non-chemistry background person also, he will think about a reaction in his or her mind, because chemistry is all about reactions. Okay, so we know from reactant to products are formed within various conditions and all. So we know this, but is every reaction in our universe, or every reaction we see or we know, are are having same speed, or are every reaction is having is actually happens? Because we know that in the books we are reading that this and this, if we mix these two, this will happen, right? Like that way we remember things. But when you are asked that how how can we say that reaction is going on, how? There is a way, right? If we ask that a reaction is happening, aldol reaction, let's say. So aldol reactions, reactants are there, basic condition is given, let's say. So the product is forming. We are writing like that. But if anyone say to you that ask you that uh, tell me that if how can you say that reaction is happening? Actually, this is happening. You are mixing. It is fine. But how can we say that? So thinking, right? Yes, you got an idea. Actually, there are two ways. So you should have two ideas in your mind. Two ways. Okay. One, if the reactant concentration decreases. Very easy. If reactant are involved in reaction, reactant concentration will decrease, and if the product concentration increases. If product is forming, we know that product is forming and it should increase also with time. Then we can say that reaction is going on. Okay. First question was how can we say that reaction is going on? There are two ways. Okay. Then, okay, reaction. Now the second question. Are all reactions completed within same time? We are mixing this kind of, let's say, two reactants and all. Uh, so reaction is going on. All reactions are completed within same time. Just think about this. I know you know the answer, right? So let's not make it very complicated. No, right? All reactions are not within same time. If it happens like that way, we are not playing with conditions. We are not adding. We will not add catalyst in the reaction, right? Because we can tune the reaction speed, and also it is a property of reaction and reacting molecule how their bonding is there, to break the bonding and make a new molecule. Various, for a new molecule to form, sometimes it's needed, and for all the reactions the product and reactant are not same, right? So obviously within same time they will not give the product, or reaction will be not completed. Okay. But okay, how can we say? We know that is fine, but we should have a method, right? To which we can actually differentiate between reactions, that yes, it is going in higher less time, it is completed in less time, it is completed in more time. How can we monitor that? Okay, you got an idea, I guess. Good. There are certain reactions can be completed instantly, and certain reactions are which are there which takes many days. Okay, you are not getting an idea. Just the explanation that no, there are certain reactions which are actually after mixing it will happen. Just like that way, some solid phase reactions are there. If we take in mortar and press it with pressure, then instantly the reaction is happening. Okay. But some reactions are also there in nature that are completed within days. Not only days, within many years. Carbon dating you also know, na? So that things are there. Half-life of various actually molecule. Uh, what to say? The these half-lives are actually many years. Okay. So that kinds of things are there. So carbon dating, and it is some scientists are actually have said that which are actually we are seeing that the door, the everything, the bed, table, everything actually reacting with nature. But the change is very small that we cannot measure by seeing. Okay, by seeing we can't say that. Let's say we have a reaction that after product formation color will be completely changed. Okay, for that point of view we can say that yes, color is changed, so reaction happened. Okay. But if not, for all the reaction color is not changing, right? And for all the reaction you can't see that reactants are losing its concentration. Yes, it's losing, and then whoosh, vanish. Is it happen like that? No, right? So in nature various kinds of things are actually reacting, but we can't see the change. But we should have a method to monitor it, right? So let's talk about this. How can we measure for a specific reaction? Question. The change of reactant or product concentration with time, which is called rate of a reaction. If we can monitor the rate of a reaction, we know for a reaction the reaction is happening, we can say to, to see that not to see that if the reactant is decreasing, product is increasing, the reaction is happening. But the speed, okay, so everyone is running. There is a program is happening or running. Like everyone is running. Let's say morning walk. Everyone has gone for a morning walk. But if we can compare, by my two friends are running. If we try to compare them, okay, they are running. Running is compared with reacting, right? But if we want to compare their running process, what should we do? The speed, he has a higher speed than than the other one. Okay, so he will finish the game or running contest. He will finish fast than the other one. Okay, that we can say. So like the speed, if we compare for the reaction, we will say the rate of a reaction. So we have to monitor the rate of a reaction. What is a rate of a reaction? The change of reactant with time. The within, let's say, 5 times, the reactant concentration decreases to some point. Okay, from 5 mole per liter concentration unit to 2 mole per liter, and time is, let's say, 5 seconds. So if we can measure the change of reactant concentration by time, means per second, that will be the rate of reaction. So rate of reaction is dx by dt, where dx is the change of reactant concentration or product concentration, but plus minus is given. Why? Because in the reaction, product concentration is actually increasing, for that plus sign will be used. And if we write the rate of reaction with respect to reactant, then we have to use the negative sign. Okay, so here everything is given. Positive sign if concentration increases. Okay. If the concentration increases, then positive sign is used. If concentration decreases, then negative sign is used. Okay. Clear? Then, okay. So R to P. One reaction is happening. Same kind of reaction. It is, if this kind of reaction is happening. So here actually, if the graph we can draw concentration, right? Only concentration if we write here in x-axis, and here time. Okay. For the product, it will increase, right? This way. Okay. This is for product, and dx dt is nothing but the slope. This is the slope actually. This, okay, this is the slope actually. Slope in this kind of change in concentration with time. Okay, but if we try to plot it with reactant, what it will be? First it has higher concentration. First it has higher concentration, then it will come to like this way with time. Okay, so that kind of things are happening here. So unit of rate. Okay, this is important. Why? You will come in the later slides. That's why it is important actually. So rate is dx by dt. Dx means concentration. Change in concentration is actually the concentration unit, right? Concentration with time, by time. Unit of concentration. What is the unit of concentration? Mole per liter. Mole per liter. Here let's say second. So overall unit will be mole dot liter dot second. Okay. So it is the unit of rate, mole per liter per second. Okay. Generally the rate, unit of the rate. Okay. Now how can we express the rate actually? This is for a simple purpose. Simply we have shown this is the rate. But if various kind of reactants are given, so what should be the rate? We can write rate with respect to A. It will decrease. It will also decrease, but it will increase. So how we can, so rate of a reaction is a particular for a reaction, right? It will not like that the rate of rate for A will different, rate for B will different. This is not like that. Rate of a reaction is particular. In this part actually, in such parts actually students make mistake. Okay, so rate of reaction for a specific reaction will be only one quantity. We can measure it with respect to A, B or C, but it will not different. Okay, so how can we write that? Let's see. Rate of a reaction is minus dA by dt, as it is reactant. Minus dA by dt equals to minus dB by dt equals to minus a positive sign is there, is not given means positive, dC by dt. Okay, that's there. Understand, you will understand it in a better way in this example. Okay, so in the case of A plus B coming to C, forming C is fine, right? But what will happen when A plus 2B is there, coefficient is 2, here 3? Okay, is it like this only? But here, if we see, we have to understand the concept. If we don't, then you will make mistake in the exam. Okay, so just try to understand. 1 mole of A, let's say, or one molecule or one atom of A is reacting with 2 atoms of B and giving 3 C atoms. Okay, or molecules. Fine. So the rate with respect to A means when one molecule A is actually given the product, one molecule A is lost. For one molecule A, 2 molecule of B is lost. So it is high amount of B is lost, right? And here more than that, three times higher C is forming. So how can we actually equalize that? We can say that minus dA by dt will be there. Fine. Minus dB by dt will be there. Fine. Plus dC by dt will be there for a rate of reaction to right. But can we equalize this all like that? Think about it. Because the rate of decreasing the concentration A is not equal to the rate of decreasing of B. But that's not the thing, right? I have told you the rate of reaction for a specific reaction will be only one quantity. But we cannot equalize this all. So am I wrong? Have I done a mistake? Think about it. But no, I have told you the right thing. But you have to properly write the expression like this way. Because DADT is rate of reaction, we know. But 2 times B is lost when one molecule A is lost. So we have to divide it with 2 because the rate of the loss or losing of B is more than A. So we have to divide it with 2 and we have to divide it with 3 for the same reason. And we can now equalize the all three. Easy? Easy, right? So we have to remember that for a reaction, if any coefficient is given, we have to divide the rate with respect to that part or that reactant or product. We have to divide the coefficient. Okay, divide, not multiply, because the rate is higher here. We have to divide. Okay, then we can equalize. Fine. Now tell me, the question is here with the same concept. The rate expression for the following reaction will be what? Rate expression only. Okay, easy. Let's write. For reactant, we know minus is there. dN2 by dt. Okay, I am not equalizing right. Just I am writing dH2 by dt. Okay, and it is also minus. And positive and d in H3 by dt. Okay, so we can't equalize it because it has coefficient, it has coefficient, it has coefficient. So how can we write? Let's say it is negative. We are making it 1 by 2. We are actually, okay, this is negative 1 by 3. This is 1 by 2. Coefficients are divided. Now we can equalize. This is equal to this. Okay, this is a negative sign. This has also negative sign. Okay, this is there. Understood, right? This will be the expression. Now, general formula for rate of a reaction like this way. Coefficients are A, B, C, and D. Okay, so rate of a reaction will be this. Coefficients are divided and negative sign for reactants and positive sign for product. Fine. Okay. Now, if you have asked you are asked the question that rate of reaction is fine, what will be the rate of formation of C? What will be the consumption of A? What will be the rate of consumption of B, and what will be the rate of formation of D? Okay, so then what will be your answer? Will you take that yes, this is rate of a reaction, so it will be only the rate of formation, rate of consumption, rate of like all the things will be same, right? Rate of reaction. But this is not. This is individually you are asked that rate of formation of C, with which rate or speed the C is forming. This is different. This will be only the dC by dt. This is forming positive, only dC by dt. No coefficient will be divided. Please make sure you will understand this portion. Rate of reaction to equalize the all thing, because rate of reaction for a specific reaction will be specific, only one quantity. It is not like for A it is different, for B it is different. It will not happen like that. Rate of reaction for a reaction will be specific. For that reason, to equalize the all rates, we have to divide every part with its coefficient. But if you are asked that rate of formation of C, for that time, for that part actually, you should not be it divided with C, like 1 by C. Okay, should not, because only rate of formation you are asked. Like that way, rate of formation of D will be this, rate of consumption of A will be this, rate of consumption of B will be this. Please, this slide is very much important. Please look into this. Please, this is very important concept. Okay, we will solve one question. Okay, this is GATE. Okay, as we are preparing for NET, GATE questions like same syllabus. Okay, so these questions are also important for us to solve. So this reaction is 2x3 is giving 3x2. The rate of formation of x2 is expressed as. Okay. So rate of formation, we know that in the previous slide we have seen that rate of formation of x2 will be dx2 by dt. No coefficient will be divided and nothing will be there. Only this is the rate of formation of x2. Clear? This is not the overall rate of formation of x2. Okay. But in the answer, the options you have seen that it is right like x3 with respect to x3. So we have to convert it. For that purpose, we have to write the rate expression, overall rate expression. So how can we write? Minus 1 by 2, divide it with coefficient dx3 by dt equal to coefficient 1 by 3, then dx3 by dt. Right? For rate of reaction, we can write, right? So we have to solve this part. We have the value of we want the value of this dx2 by dt. Sorry, this will be x2, right? Yes. Don't make this kind of mistake. Okay, dx2. So dx2 by dt. Here 1 by 3 was there, so it will minus. So it will go up, and this will be down again here like this, and dx3 by dt. Okay. So this is actually equal to this one, minus 3 by 2 dx3 by dt. Minus is here, 3 by 2 dx3 by dt. This will be answer. Answer D. Answer will be D. Fine. Okay. For a reaction 2A plus B giving 3Z, if the rate of consumption of A is rate of consumption of A, what is that? Consumption D A by dt. Their numbers are given, not only expression. So it is 2 to the power 2 into 10 to the power minus 4 mole per decimeter cube second inverse. This is liter and only. Decimeter cube. Okay. Decimeter cube is actually liter. Okay. So liter inverse means decimeter to the power minus 3. Right? Okay. This is only concentration and per second. Like yes, the rate kind of the same unit of rate. Okay. So rate of formation of Z will be, okay. So the question the question actually wants this value, rate of formation of Z, dZ by dt. This actually the question wants. What it is the value of this. Okay. Okay. So to write the rate expression, we have to again write the rate expression, right? So that we can compare this with this. Okay. So then write the rate expression. Write the rate expression here. So minus 1 by 2 dA by dt. Okay. So it is equal to, no coefficient is there, so only dB by dt, and minus will be there obviously, equal to 1 by 3 dz by dt. Clear? Okay. So we want this value. We know this value. Okay. So write only, this is not needed. This is not needed here. So let's just cut it down. So what answer we actually want? This one. This answer we actually want dz by okay. So dz by dt equal to actually 3 by 2, right? This is actually easy. Dz by dA by dt minus. Okay. So this is actually given equals to 3 by 2 into 2 into 10 to the power minus 4. I'm putting this value only. Okay, nothing. 2 will be cut down and 3 into 10 to the power minus 4. This will be the answer of rate of formation of Z. Clear? This is the answer. I hope you understood it now. Okay, now different topic, type of reactions. Two type of reactions generally, like we can define reaction various way, but here we are defining like to see the steps. It can be elementary, having only one step. It can be multi-step reaction, complex reaction. Okay, it has multiple steps. So for elementary reaction, it is simple. But for complex reaction, any one step is the rate determining step. Any one of the steps. It has multiple steps, but any one of the steps is rate determining step. So now question is, how can we say that which step is rate determining step? Okay, I will tell you one example, real life example. Okay, again the running contest. Okay, it is happening, competition is there, so various teams are there, team A, team B, team C. Okay, fine. Team A has 5 contestants, team B has 5, team C has 5. So 5, 5, 5. Okay, so one team will win the race when the all 5 contestants actually finish the race. Clear? A, B, C all having 5 contestants each. So one team, if A win the race or B or C, all the 5 contestants should finish the race faster than other. Okay, let's not think about B or C. For only one, like A, let's say team A, when it can finish the race, 5 contestants it will have. When 5 contestants actually finish the race, right? So the depending on this, how can we tell that on which parameter or on which contestants among the 5 the rate of their winning or their winning probability will depend on which contestant among the 5. Is it who is running faster, or is it which running slower? Now think about it. We will say that who is running faster, right? Who will finish the race faster than anyone, fastest. Okay, finish the race fast. But what I said, the team A will own the race only if the 5 contestants will reach to the point, finish the race. So it will depend on the slowest contestant. The faster will reach, but to win the race, all 5 of them should reach that point. So which is slower? It will depend on the slower participant to win the race, because it will take much time. It will take much time. So if we can make him courageous, or we will cheer him up, so if he runs faster, then that team can win. Like that way, for the complex reaction, it has multiple steps, like 5 contestants. But the rate of reaction will depend on the slowest, because faster will give a product in the fastest way. That will not a problem. But to complete a reaction, whole complex reaction, all the steps should be completed, right? So the step which is slowest, it will depend on the slowest step, that the complex reaction is completed or not. Okay, so the overall rate will depend on the slowest step, so it is called the rate determining step. This concept is very much important in the case of organic chemistry also, and also chemical kinetics. So various this concept of this is very important, so keep that in mind. Okay, moving forward, rate law of reaction. Now what is this? We know that, right? We know the rate expression. So why we need to read the rate law of a reaction? Now what is this? Okay, so rate law, it is not we can write like seeing the reaction like previously. The rate expression we are writing by seeing the reaction, but it is actually it is experimentally determined quantity. Okay, so why it is coming actually? So reaction rate is actually depending on various factors. One of the important factor is the concentration of product and reactant concentration. Okay, so to change the reactant concentration, we can actually change the rate law in various ways. So how actually changing concentration actually uh, effect on the rate of reaction, that actually rate law tells us. Okay, so if this is actually if any kind of reaction, so rate law can be expressed by k into a to the power x b to the power y, where x is the not the coefficient. We cannot put 2 here. Okay, x and y are the x and y are the x and y are order with respect to a with respect to b. So overall x plus y will be the order of reaction. Okay, so we will come to that part in the later slide. Order is order and molecularity comparison is also there, so we will find that. But only you should remember that this is experimentally determined quantity, and rate law can be expressed as this is actually rate constant. Okay, and the concentration of both the reactants should be there, and it has power of the specific order with respect to that reactant one. Okay, so to understand it properly, how the rate law actually came, how we can determine. Let's take a simple example. Let's say we have done one experiment one. If A is increased by 2 times, what is happening? It is actually experimentally can be seen. It will be increased by 2 times. What is important here? 2 times it has increased A. It is increased by 2 times. Experiment 2 is if B is increased by 2 times, rate will be increased by 4 times. So how it is actually? It has an impact. So as it if A is increased by 2 times, the both are actually increased in the same amount. So how can we write that? Rate is now proportional to A. Fine, only with respect to A concentration. And here rate is proportional to B. No, because 2 here 4. So we have to put here order like that way, so that we can got the 4 time increment. So when B is increased by 2 times, let's say here 2 if we put, so here the power should be 2 to get rate increment 4. Right? We will solve some questions, you will understand in a better way. So overall rate expression here will be rate constant A and B to the power 2. Okay. This will be the overall rate here. How can we determine that? Did we put the coefficients only? No. We have done 2 experiments. Seeing the result, we have determined it. So that's how actually rate law comes into our chapter. Now, order and molecularity of the reaction. In the order, you have previously see that in rate law expression order is there. So difference between order and molecularity. This is very important, and we have also we know that I will simply just tell this thing. So the number of molecules which come together and collide to occur a reaction. This is molecularity, which is expressed in the coefficient. We can join the number of coefficient and we will get the molecularity. Fine, for each step actually. So I'll come to that. So molecularity is only that thing, and order is the sum of power of concentration term involved in the reaction. Sum of power of concentration term. So in the previous case, here, what will be the order? 2 plus 1. Order will be 2 plus 1 equal to 3. Third order. Okay. So order is 3 here. So you'll understand sum of the power of the concentration term. It is theoretical concept. It is experimentally determined quantity. Okay. And it cannot be 0 because molecularity, one molecule is needed to perform a reaction, right? So molecularity can't be 0 or fraction or negative. Negative and fraction to almost beyond our mind, right? It is always a whole number because it is a quantity, number of molecules actually. But it is experimentally determined, so it can be fraction, negative, and also 0. Remember this. It can be applicable only for elementary step reaction. Elementary reaction, for complex reaction, it will vary in all steps. Why? Because molecularity is the stepwise. In each step, how much molecules are actually colliding. Okay. So for the elementary reaction, it is fine. By seeing only the reaction, we can say that it is the molecularity is this. Like for example, if we take here 2A plus B giving product. Let's say product. So what will be the molecularity? 2 plus 1, 3. Okay. But for the complex reaction actually we should know the all steps and it will vary in all steps. Okay. And here it can be applicable for both the elementary and complex reaction because it is experimentally determined. So it will not depend that it is elementary or not, complex reaction or not, like that. Okay. So let's say 2A plus B equal to product, rate is this and order will be then x plus y. Clear? So what is molecularity and order again. So this is the rate law, order is this, and remember this is important. For elementary reaction, order will be molecularity. This is only for elementary. This is, we know the differences, right? But for elementary reaction, let's say this reaction, order will be molecularity. How? So here rate is given like this, and here x will be 2, y will be 1. So it is third order reaction and molecularity will be also 3, right? Because it is one step reaction, only 2 number of A and 1 number of B are involved in the product formation. That's why it is happening actually. Experimentally also we got the same thing. One question from GATE again. So for the reaction P plus Q is plus R is giving S. Experimental data for the measured initial rate is given below. Okay, these kind of questions are actually generally asked. Okay, but seeing this, you will think that it is very complicated. Various data are there, but if we solve carefully, you can actually. Okay, so see, initial concentration of P is given, Q is given, R is given with initial rates. Okay, rate is given. So we know that first rate from the rate law, rate equal to rate constant p to the power x, q to the power y, and r to the power z. Okay, where order is x plus y plus z. Fine. Okay, so we should know the values of three things. Now in the question, okay, to solve it in the easiest way, what you should look into, you should see that for which given the four datas, which data some parts are actually constant, so that you can, after dividing, you can clear these parts, right? It will be easier because three terms are there, na, x, y, z. So I'll solve with you. Solve it with me, please, to understand, to have a clear idea. So here you can see these two are same, these two are also same, rate is different, and P, the initial concentration of P is different. Okay, so we will write the rate expression for these two. For the first one, rate is 8 into 10 to the power minus 5 equals to K A, sorry, not A, P to the power. Okay, we are writing for first one, p to the p to the power x. Okay, so in the case of p, I will write the values only because concentration is given, right? So point 2, not mean third bracket, first bracket I can give. Okay, 0.2 to the power x and 0.5 to the power y and 0.4 to the power z. Clear? Here. Next, for the first one, we have right. Second one, rate is 3.2 into 10 to the power minus 4. Okay, equals to k 0.4 to the power x, same 0.5 to the power y, 0.4 to the power z. Fine. So this is 1 and this is 2. I will divide 2 with 1, 2 by 1, 2 by 1. Okay, because it is bigger, na? So that's why. So it will be, okay, I am writing for you guys. So if I write like 32 only, so it will become 10 to the power minus 4. Right? Same thing, na? 8 into 10 to the power minus 4. Then I am only multiply here with 10 and divide here with 10. Same thing, as it is multiplicative nature is there. So this. Now if we divide, I will not write, just see these are same, so it will be 1. These are same, this will be 1. All are multiplication here, multiplication. Okay, and k will also remove. So here 0.4 by 0.2 whole to the power x, right? So what it is giving here, 8, right? 8. No, sorry, 4. Oh, childish mistake. So here, sorry, 4. Okay, so here 4 into 10 to the power 5 is also there, not, okay, not 4 into, only 4. Okay, so 4, and here again equal to, okay, 2 to the power x, right? And if we write 2 to the power x equal to 4, equal to, we can write this as 2 to the power 2. So then x will be 2. We have one, we got one value, x equal to 2. Now, okay, that is there. Now, the again. So we have to again see the most parts are actually if common, then it will be easy. These are always different. These two are same. These two are same. See, now we can get the y value. How? I'm solving it for you to have the clear actually view. Okay. So again, what was that? Rate. So I am writing for 2. 2 actually it was written. Okay. This again. 3.2 into 10 to the power minus 4 equals to P 0.4 to the power x into 0.5 to the power y and 0.4 to the power z. 3 equals to, rate is 1.28 into 10 to the power minus 3. Okay, equals to, again same, point, sorry, 0.4 to the power x. It will be different like 2. 2 it will become, and 0.4 to the power z. Right? Clear? So if we divide 3 by 2, what it will be? Then it will be, we are as it has higher value, we are dividing 3 by 2. Okay. So here, so 12.8 into 10 to the power minus 4. Again, I have done same thing to actually cancel out these things. 10 to the power minus 4 to 3.2. Okay, fine. Equals to, okay, this has gone 2 by 2. Yes, 2 by 0.5 to the power y, and this will be also gone, right? Okay, so it is, so 4, again 4, right? 4, yes, 4, and it will be also 4, right? Yes, 4. 4 to the power y equal to 4. Clear? So it means 4 to the power 1. It means y equal to 1. We got two values, right? Only one value is needed. So how can we actually solve that? Now, okay, let's see. Okay. Only this z value is changing for this part. Okay. So, no, there will be no easy way. We have to solve it this way only. So 3, it is written right for 3. So for 4, I will write here. Rate is 4 into 10 to the power minus 5 equal to 0.1 to the power x, 0.25 to the power y, and, okay, this is different, and 1.6 to the power z. Fine. Then I will divide it with 3, 4 by 3. Is it fine, or I'll divide, okay, this is, okay. No, I will just 3 by 4 I'll do. Okay. 3 by 4. Okay. 3 is there. So 128 into 10 to the power minus 5. Just see, I have shift this the point, and 10 to the power minus 5 it will become, and 4 into 10 to the power minus 5 it will become, and again, so here these things are there. 0.4 by 0.1 to the power x. See here 0.1, 0.4 to the power x into again this one 2 by 0.25 to the power y, okay, into z for z, okay, 3 by 4 we are going like that, right? 0.4 by 1.6, yes, 1.6, 0.4 by 1.6 to the power z. Okay, so now we have to solve this with x equal to 2 we got and y equal to 1. Okay, now so it will become 32, right? 4, 3, 12 and 4 into 2 will be 8, right? And this will cut down and here, so point will be gone and 4 to the power x, 4 to the power x means 2, okay? And now here 2, 2, so 200 by 25, 200 by 25, like if we solve this 200 by 25 it will be and will be 8, right? Yes, 8. So 8 y means 1 into what will it be? 4. It will be 1 by 4 into z. It will be like that only, right? Because 4 this will be gone and 4 by 4 this. Okay, equal to 32 we got now, 32. Okay, 32. So it is 16 and okay, so I will solve here only like this way. Okay, so here is very big problem now. So I am solving it in a simplest manner and explaining all the things. That's why it is taking time. But in the exam, it will not create much problem. So 4 to the power minus z actually. Okay, 32. So 4 to the power minus z will be 32 by 16 into 8 to 4. So it means 1 by 4. Again, I am writing like that 1 by 4 to the power z equals to, okay. So I think I have to, okay, I am removing this part, okay. I think you have write it down. Please pause it and write it down, okay. I am removing this part. Okay. So now, what is happening? I am clearly writing here only. Okay, clearly. So here, 1 by 4 to the power z equal to, here we got 1 by 4 only, 1 by 4. Okay. So 1 by 4 I got. Okay. So z will be 1. Yes. So z will be 1. So what we got actually, we know we have found x equals to 2, y equals to 1, z equal to 1. So order will be x plus y plus z, which means 2 plus 1 plus 1, 4. This will be the answer. Okay. Overall order is this and PQR will be 211, right? 211. So C will be the answer, 211. Okay. Now, when volume of the container is double, rate decreases 8 times. When A is double, B is half. So one by one I write. When volume on the for a reaction, okay, for a reaction A plus B plus C, okay, giving product. So what is happening? When volume of the container is double, rate is decreased by 8 times. So for concentration, we know mole per liter means volume. Volume is in the uh, denominator. Okay. So which means when we are increasing double the volume, it will concentration will be halved. Okay. So here rate expression will be, so first write the rate expression. So rate will be K into A to the power X, let's say, B to the power Y, and C to the power Z. Okay, fine. So now if when the first thing is done, volume is half, what will be the rate? So rate is, say, R equal to rate. So R is decreased by 8 times. R by 8 then, fine. And the concentration is halved actually. So A by 2 to the power X, B by 2 to the power Y, and C by 2 to the power Z. First thing done. This is first. Okay. Then when A is double, B is half. Rate increases 8 times. Increases 8 times. So second one, sorry, increases 4 times. 4R equal to K into, so what was the concentration of A? A is double, means 2A to the power X. B is half, B by 2 again to the power Y, and C is same, means, okay, sorry, C is same means the like previous one. Okay, so C is C to the power Z. This is second. Third one is when C increases 4 times alone, everything is same. Rate increases 64 times. Okay, 64 R equals to K. All the other things are same. A to the power X, B to the power Y, and C is increased 4 times. 4C to the power Z. Okay, so this is 3. Now we have to know the value of X, Y, and Z, so that we should write down the rate expression, rate law expression, and order. Okay. So for that, what should we do? So tell me, what will be the easier way? So here, all the things are actually fixed. Only C is different. So we actually, if we divide it with this main rate law order, this one. Okay. So I think this should be 1. This should be 2. This is 3. This is 4. 4. Okay. So it will confuse you. I will just, the conditions are there. Okay. So now what should we do first? If we divide 4 by 1, then all the things will be cancelled out. Okay. Just dividing 4 with 1. Okay. Now 64 equals to, everything will be gone, only 4C by C to the power Z. C will be gone also. So 4 to the power Z. Okay. So 4 to the power Z means 4 into 4 into 4. If we write, then it will be 64. So Z will be actually if we write 4 to the power cube, then it will be 64. Then Z is 3. Okay. Then you just actually solve it down. I have solved you this much. Then you can actually, the value of Z now. So you can just divide this one and this one. 3 by 2. Okay. Then you see this will be cancelled out, and C you know actually. C will be cancelled out and Z value you know. Then you will find the X value. If we divide 3 by 2, okay, you will find the Y will be cancelled out, and you will find the X value. Okay, I am not solving. Okay, this you will do, and then we know the Z, and to know the Y value you have to divide it then with anything, like you have to divide it with 3 by 2. Okay, then 3 by 1 you can, 3 by 1. Okay, fine, then it will give the Y value. Okay, do it yourself and write down the answer in comment section. I will check. I hope you have understood these kind of questions. This actually this comes in the exam. So many times what is happening is there students are confused with all the datas and all. But if we clearly actually write the all the things and then divide, we have to just think that dividing which with which gives you the simplest form, right? Like this, the many of the terms will be gone, and so that we have only one value. We can actually three kind of values are there, na? Three values. So our target is first to have the uh, one value at least, so that we can simplify. So sometimes questions are very tough that we have to deal with all the values. We can cancel out all the things, but that time it will be more lengthy, but not tough. Okay, so now the one quick thing I will do, rate constant. So we have read that actually. So the okay. So rate is, we know that rate is this, right? K into rate constant into a to the power x, b to the power y, where x plus y is order. We know these things, right? And K is the rate constant. So K will be the main important thing about rate constant is not its definition, nothing. Main important thing is unit of rate constant. You will find various questions with that. But it is very simple. Sometimes students are actually struggle with that of what it was, I can't remember. But if you just know the rate law, you will never forget it, right? Because K is here rate by this. Okay, then rate by concentration to the power x plus y, where x plus y is the order. So we can say that rate constant, the unit of rate constant will depend on the order of the reaction. This is very important. Not only that, for every reaction rate constant value or unit is same. Constant value can be defined, it is fine, but unit, we previously every quantity we have read, we got a specific unit for that, because like for concentration, volume, energy, everything has a constant or same a specific unit. But for the rate constant, it will depend on order of the reaction. So you have to have the idea of the order of reaction before write down or the unit of rate constant. Please remember this one. So this is the main important thing here. After that, we know that rate is dx by dt. So change of concentration over time. So mole per liter per time, okay, but or second inverse. And again in below, concentration to the power order, so mole per liter to the power order. Let's say order is we have taken like n. Okay, so mole per liter this. So if we simplify this thing, we got that. Okay, it is actually, it will be here. Okay, ignore this one. So K will be mole per liter to the power 1 minus n, because here is also there 1, we can say it is 1 to the power, and here n 1 minus n into time inverse 1. Okay, so this will be the rate constant. We will see again the rate constant when we read about first order, second order, third order, zero order reaction. So various reaction. So I'll not go to the expression how it is coming and all, but I will show you the formulas and the questions how can be tackled. That I will show you maybe in the next topic itself, but or some other session, but I will show you. Okay, so till this I will finish. So please remember this K formula to solve the questions. It will actually help. So concentration to the power 1 minus A into time to the power minus 1. Okay, so with that I will conclude. So I hope you enjoyed the session, and feel free to comment down if anything you are not understanding or something you are actually struggling with. I will happy to help you, and the answers which I was actually not given to you, please write down the answer. I have show you how to solve, and one question I have solved you in front of you. I have solved to you. Okay, in front of you I have solved it. So please try. If you try and if you try to solve the various questions and practice is more, you will learn more. Okay, so comment down below the answers, and okay, see you in the next class. Till then, bye and thank you.